This is integrated 3. It is problem 10-33, and it says the theater class has 4 backdrops to paint, and they only have enough crew members to paint one mural at a time. They need to prioritize the order in which to paint the murals. And how many ways can they prioritize the painting of the murals? Well, sometimes it's if there's small numbers of stuff, you can just list all the different ways and count them, and that's probably the easiest way to do it. But in this case, I started trying to imagine, like, what is the question asking me? It's saying that, like, let's say this is the flowery backdrop for the play, and this is the one with the forest trees, and this is the one with the starry night, and this is the one, I don't know, with the hearts on it. So they have to paint these 4 different things, and they have to paint them in a certain order. So they want to know how many different orders can they paint them. Like, they can go flower, tree, flower first, then tree, then star, then heart, or maybe they could go flower first and then star, then heart, then tree. And you can see I put numbers on each of the backdrops just so I could keep track of them instead of having to write pictures. And I started listing them, and then I realized that it's going to be a pretty long list. Like, if they do the flower first, I tried to find all the different ways, all the different orders they could do the flower. Like, they could go flower, tree, star, heart, or they could go flower, star, heart, tree. Like, you can see I'm trying not to repeat any of the orders. But I see that that would be a long job for me. And so I know that there's a shortcut for this. It showed up in a math notes box. You guys were supposed to learn it last year, but I don't think you did. I did a video on this already, but there's these things called combinations and permutations. And this is, I'm going to make a little hat out of this. So in the permutations, that's the one we want because that's when the order matters. In combinations, the order wouldn't matter, but this is asking us specifically how many different ways can I, like, what order should I paint these in? Like, how many different orders can I go? I can go flower first. I could keep going. I could say, oh, let's try paint the tree first. Well, I could go 2, 1, 3, 4, 2, 3, 4, 1, 2, 4, 3, 1. 2, 4. You can see that I can, like, I'm going to get a whole bunch of numbers just by painting the tree first, right? I could just make more, and then it's going to be a lot of numbers because I could do that same thing with the stars and with the hearts. So actually, I mean, at this point, you might notice that there's, I think there's only 6 different ways to do it with the flowers first. And if I try real hard, I would probably find out there's probably 6 different ways to do it with the tree first and probably 6 different ways to do it. So I'll bet, I think the answer is going to be 24 just by common sense and looking at my list. But I want to go ahead and use our formula for the permutations. So what this says is that if you have n things and you're taking them r at a time, then you can find out how many different ways, how many permutations there will be by going n factorial over n minus r factorial. And so I did make a separate video called Permutations and Combinations, and that's in the Google Classroom if you want to look at it. But basically, we've got 4 things because they're 4 murals, and we're trying to, like, put them in order. We're going to do them 4 at a time, but there's the order matters, so there's different ways, different orders that we can order these 4 numbers. So we're doing 4 things taken 4 at a time. So this is n, and this is r. So for n, I plugged in a 4, and then for n minus r, 4 minus 4 is 0. And so 0 factorial by definition is equal to 1. And then factorial, the way factorial works, you even have a button on your calculator. What it does is it takes the number and it multiplies in descending order by the integers, like 4, 3, 2, and then you stop when you get to 1. So it turns out I can quickly use a permutation to find out that there's 24 different ways I could order these to be painted. And I think this way is faster than listing them all out.